Hi, 6th grade. So if you're watching this video, it's because you didn't get a chance to finish the metals, nonmetals, and metalloids graphic organizers today during stations. So if you finished those already, you don't need to watch this. But if you didn't get a chance to, this is your chance to take those notes. So let's get started. I'm going to zoom in on this just a little bit. So, let's start. What are the properties of metals? So I'm going to start with metals, and we're going to look for our examples that we have here, and we're going to look for our characteristics. So be keeping those in mind while I read. So, what are the properties of metals? It's hard to imagine modern life without metals. The cars and buses you ride in are made of steel, which is mostly iron, Fe. Airplanes are covered in aluminum, Al. Copper, Cu, wires carry electric current to lamps, stereos, and computers. Can you identify the objects that contain metals in figure 1 below? We won't do that. Elements can be classified by their properties, including melting point, or melting temperature, density, hardness, and thermal and electric conductivity. Metals are elements that are good conductors with electric current and heat. They also tend to be shiny and bendable, like copper wire, for instance. The majority of elements in the periodic table are metals. The metals begin on the left side and extend across the periodic table. So there we got some examples, right? So let's go back. We said, let me answer a text box just real quick. We said aluminum, and the other one that we said was copper. So we have those done already. Let's move on to the next page. So, physical properties. Figure 2 shows some common metal objects. The physical properties of metal include luster, malleability, ductility, and conductivity. A material that has a high luster is shiny and reflective. A malleable material is one that can be hammered or rolled into flat sheets or other shapes. A ductile material is one that can be pulled out or drawn into long wires. Copper is both malleable and ductile. It can be made into thin sheets or drawn into wires. Thermal conductivity is the ability of an object to transfer heat. The ability of an object to carry electric current is called electrical conductivity. Most metals are good thermal conductors and electric conductors. Metals also generally have low specific heats. Recall that specific heat is the amount of energy required to raise the temperature 1 gram of a material by 1 Kelvin. This means that only a small amount of thermal energy is required to raise the temperature of a metal. Some metals are magnetic. Iron, cobalt, and nickel are attracted to magnets and can be made into magnets. Most metals are solid at room temperature. Only mercury is a liquid at room temperature. So let's go back to our notes. What were some other things that it said? Well, it said that metals were malleable. That's spelled correctly. I think it is. Yeah, malleable. which, if you noticed, some synonyms for malleable are soft and flexible and bendy. It also said that metals are ductile. And the last one that it said was that they were good conductors of heat and electricity. Just let me fix that so you can see that okay. There. And now we have metals done. So let's move on to nonmetals. Nonmetals. What are the properties of nonmetals? Life on Earth depends on many nonmetals. For example, carbon, nitrogen, phosphorus, hydrogen, and oxygen are all nonmetal elements found in your body's DNA. A model of DNA is shown in Figure 1. While many compounds made with nonmetals are essential to life, some nonmetals are poisonous and highly reactive. Still, others are non-reactive. Compared to metals, nonmetals have a much wider variety of properties. However, nonmetals do have several properties in common. So let's stop there. We already have two examples. We have oxygen, and another one you could put is hydrogen. So now let's move on to the properties. Physical properties. A nonmetal is an element that lacks most of the properties of a metal. Except for hydrogen, the nonmetals are found on the right side of the periodic table. In general, most nonmetals are poor conductors of electric current and heat. Solid nonmetals tend to be dull and brittle. If you were to hit most solid nonmetals with a hammer, they would break or crumble into powder. Also, nonmetals usually have lower densities than metals. Many nonmetals are gases at room temperature. The air you breathe contains mostly nitrogen and oxygen. Some nonmetal elements, such as carbon, sulfur, and iodine, are solids at room temperature. Bromine is the only nonmetal that is a liquid at room temperature. So let's go back. So we already know that nonmetals are dull. So it also said that nonmetals are brittle, which means they break easy. It said that they are poor conductors of electric and thermal energy, which you can't see, so let me fix that real quick. Okay. Just a little bit smaller. There we go. And it also said that they tend to have a lower density. Oh, it's killing me. There. Now nonmetals are done. Last one. Metalloids. Oops. Metalloids. Metalloids, between the metals and the nonmetals in the periodic table lie the metalloids. The metalloids have some properties of metals and some properties of nonmetals. All metalloids are solid at room temperature. The metalloids are brittle, hard, and somewhat reactive. Oh, so there are some other things already we can put on our list. So we already have that they're brittle. So we can put that they are hard and that they are somewhat reactive, which means they react only sometimes. The most common metalloid is silicone. Ordinary sand, which is mostly silicon dioxide, is the main component of glass. A compound of boron and oxygen is added during the process of glass making to make heat-resistant glass. A metalloid's most useful property is the ability to conduct electric current. The conductivity of a metalloid can depend on temperature, exposure to light, or the presence of impurities. For this reason, metalloids such as silicone and germanium are used to make semiconductors. Semiconductors are substances that can conduct electric current under some conditions, but not under other conditions. Semiconductors are used to make computer chips, transistors, and lasers. Semiconductors are also used in solar cells, such as the one shown in Figure 8. So let's go back. I'm looking for two examples. So one of them was boron. Let me make that a little bigger. And the other one was germanium. And that's it. So you should have all this stuff written down now, and make sure you have it with you in class tomorrow. All this stuff will go in your science binder. So on that note, guys, have a good night.